Beneath the surface of Yellowstone National Park, a concerning change is happening, and scientists have recently announced an alert. Renowned podcaster Joe Rogan has recently shed light on the massive dome-shaped uplift in the park that is increasing in size. But is Yellowstone's sleeping giant showing signs of awakening? And if so, what could the consequences be for us? Let's dive into the facts and explore the significance of this growing dome-shaped uplift. The Yellowstone supervolcano. A sleeping giant found in the American West, Yellowstone National Park is a marvel of nature's beauty. It also sits atop a ticking geological time bomb, which is the Yellowstone supervolcano. This supervolcano is a colossal force of nature, with the potential to unleash devastation on a scale we can hardly comprehend. The history of Yellowstone's volcanic activity is both fascinating and a bit terrifying. The area has witnessed massive eruptions, the likes of which are hard to imagine. And now, according to Joe Rogan, the huge dome-shaped uplift is increasing in size and worrying scientists. The Huckleberry Ridge eruption set a precedent for the immense volcanic activity that defines Yellowstone's geologic history. This eruption, one of the largest in the Earth's recent history, formed the initial Yellowstone caldera, a massive volcanic crater that remains a central feature of the park today. Following this colossal event, the area witnessed two more significant eruptions: the Mesa Falls eruption around 1.3 million years ago, and the Lava Creek eruption approximately 640,000 years ago. Each of these eruptions contributed to the complex volcanic landscape of Yellowstone, shaping the region's topography. The Mesa Falls eruption, while smaller than the Huckleberry Ridge event, was still of monumental scale. It produced widespread ashfall that covered large areas of the current United States, further transforming the landscape and impacting the environment. The opening formed by this eruption partially overlaps with the earlier Huckleberry Ridge opening, illustrating the ongoing volcanic activity beneath Yellowstone. The most recent of the three, the Lava Creek eruption, was responsible for the formation of the present-day Yellowstone caldera, the park's largest and most notable volcanic feature. This eruption was so vast that it ejected a massive volume of volcanic material, with ash reaching as far as the Mississippi River and the Gulf of Mexico. The aftermath of this eruption saw the creation of the opening that spans almost the entire width of the park. These eruptions have had huge effects on the global climate, influencing weather patterns and leading to cooler temperatures worldwide. The ash and gases released into the atmosphere during these events would have had a significant impact on the Earth's climate system, likely leading to volcanic winters, where the sun's rays were partially blocked, reducing global temperatures. Such climatic disruptions could have affected ecosystems and wildlife, leading to changes in species distribution and possibly contributing to evolutionary pressures on plants and animals. In addition to their climatic impact, these eruptions have played a crucial role in forming the unique geothermal features that define Yellowstone National Park. The repeated emptying and refilling of the park's magma chamber have fueled the formation of its renowned geysers, hot springs, and other hydrothermal wonders. The heat driving these features comes from the still-active magma chamber beneath the park, a direct link to the volcanic eruptions that shaped Yellowstone's landscape millions of years ago. Today, the evidence of these ancient volcano eruptions provides invaluable insights into volcanic processes and the Earth's geologic history. The layers of volcanic rock and ash deposited by these eruptions serve as a geological record, allowing scientists to piece together the timeline of volcanic activity in the region. This record is important for understanding Yellowstone's past and also for predicting future volcanic behavior and assessing the potential risks associated with the park's supervolcano. As such, the study of these eruptions and their aftermath continues to be a crucial aspect of geological research in Yellowstone. At the heart of the volcanic activity occurring today is the Sour Creek Dome and the Mallard Lake Dome. These domes are not your typical volcanic structures. They're more like giant blisters on the Earth's surface, formed by the upward pressure of magma refilling the opening's magma chamber. To understand the significance of these domes, imagine a giant underground balloon filling up with magma. As this balloon expands, it pushes the ground above it upwards, creating a dome shape. This is essentially what's happening beneath the Sour Creek and Mallard Lake areas. These domes are massive, stretching over several kilometers in width and rising hundreds of meters above the opening floor. And recently, something strange is happening to these that scientists have noticed. The presence of these resurgent domes is a clear sign that the volcanic system beneath Yellowstone is far from dormant. In fact, it's an indication that beneath the park's serene lakes and majestic geysers lies a restless giant biding its time. The increasing size of the dome-shaped uplift, as recently announced, serves as a reminder of the dynamic and potentially dangerous nature of this supervolcano. The Yellowstone supervolcano is a sleeping giant with a history of cataclysmic eruptions that have reshaped the landscape and affected global climate. The formation of the Yellowstone caldera and the resurgent domes like the Sour Creek Dome and the Mallard Lake Dome are proof of the ongoing volcanic activity beneath the park. Understanding these geological features is crucial, as they offer clues about the behavior of the supervolcano and the potential risks it poses. Recent observations and warnings. However, in recent times, Yellowstone National Park has been the center of heightened attention due to a series of unsettling signs pointing towards increased geological activity. Among these, the most notable is the significant increase in the size of a dome-shaped uplift within the park. This is a massive alteration in the park's very foundation, suggesting that the forces beneath Yellowstone are stirring. Adding to the concern are the mysterious shifts in the water levels of Yellowstone Lake. Scientists have observed that the lake's water isn't as stable as it once seemed. Instead, it's been tilting like a seesaw, indicating something powerful and dynamic is happening beneath the surface. This tilting of the lake is a red flag signaling changes in the volcanic system below. Furthermore, the appearance of long fissures in the ground has led to widespread speculation and concern. These fissures are potential indicators of magma movement beneath the park's surface. The presence of these fissures suggests that the volcanic activity underneath Yellowstone is a very real and present danger. The recent observations in Yellowstone, from the growing dome-shaped uplift to the shifting water levels and emerging fissures, are clear indicators of increased volcanic activity. These signs have played a crucial role in raising public awareness about the potential dangers of Yellowstone. The science behind the activity. But why exactly is this activity happening now? Yellowstone National Park is a living laboratory where the Earth's inner workings are on full display. Central to Yellowstone's geological mystery are the resurgent domes, particularly the Sour Creek Dome and the Mallard Lake Dome. The importance of these domes extends beyond their physical presence. They are key indicators of the restless nature of the volcanic system underneath Yellowstone. The movement and growth of these domes provide critical clues about the behavior of the magma chamber and the potential for future volcanic activity. Monitoring such a dynamic and complex system requires advanced technology, and scientists have made significant strides in this area. Modern techniques like global positioning system and interferometric synthetic aperture radar are at the forefront of these efforts. The global positioning system is used to precisely measure ground movements, allowing scientists to track the slightest shifts that could indicate volcanic activity. Interferometric synthetic aperture radar complements this by using radar images from satellites to map ground deformation over large areas. These technologies have revolutionized our ability to monitor volcanic activity, providing detailed and continuous data that was previously unattainable. Recent scientific findings have shown the importance of this advanced monitoring. The discovery of the increasing size of the dome-shaped uplift is a case in point. This significant change hints at the movement of magma beneath the surface and could signal an increase in volcanic activity. Similarly, the Hidden Falls fissure, a massive crack that appeared seemingly overnight, has captured the attention of both scientists and the public. These discoveries highlight the dynamic nature of Yellowstone's geology and show the need for ongoing vigilance. The implications of these findings are huge. The advances in monitoring technology have provided us with unprecedented insights into these processes, allowing scientists to track the park's volcanic activity with remarkable precision. Potential consequences. The potential eruption of the Yellowstone supervolcano is a scenario that carries with it catastrophic consequences for the immediate vicinity and potentially for the entire globe. One of the most immediate effects of such an eruption would be the widespread fallout of volcanic ash. This ash, much like fine abrasive sand, would blanket landscapes, smothering everything in its path. This fallout could disrupt transportation networks, burying roads, railways, and airports, and bringing travel to a standstill. But the impact of ash extends far beyond mere inconvenience. The weight of accumulated ash could cause buildings to collapse, power supplies to be disrupted, and lead to significant structural damage. Furthermore, this ash, loaded with sharp particles, poses a serious threat to respiratory health, capable of causing severe problems if inhaled by humans or animals. The environmental damage would be massive. Ash and volcanic gases can lead to the contamination of water sources, making them unsafe to drink and harming aquatic ecosystems. The sulfur dioxide gas released during the eruption could mix with water vapor in the atmosphere, falling back to Earth as acid rain. This acid rain would devastate ecosystems, acidifying lakes and rivers, damaging plant life, and corroding built structures. Beyond the environmental impact, a Yellowstone eruption could usher in a volcanic winter. The massive amounts of ash and gases ejected into the atmosphere would form a dense cloud, blocking sunlight and leading to a significant drop in global temperatures. This sudden cooling could have dire consequences for agriculture, leading to widespread crop failures and food shortages. In a world heavily reliant on stable agricultural outputs, this could result in a global food crisis, with shortages leading to increased prices and potential famine in more vulnerable regions. The societal impacts of such an eruption would be far-reaching. Infrastructure damage from ash fallout and seismic activity could disrupt essential services, from healthcare to the supply of electricity and water. The health hazards posed by ash and volcanic gases could lead to increased strain on medical services, with respiratory issues and other health problems becoming more prevalent. Joe Rogan's unfiltered views. Joe Rogan has an interesting view about the recent incident in Yellowstone. Joe Rogan, a renowned commentator and podcaster, has a knack for delving into complex issues and bringing them to the forefront of public discourse. His discussions on the Yellowstone supervolcano are no exception. Rogan has raised strong warnings about the potential dangers hidden beneath the serene landscapes of Yellowstone National Park, capturing the attention of his vast audience and amplifying the conversation around this geological giant. Rogan highlighted the sheer power of the supervolcano and the massive impact its eruption could have on the surrounding region, and potentially on a global scale. Through his platform, Rogan has succeeded in painting a vivid picture of the supervolcano's might, drawing from the well of scientific findings to underscore the seriousness of the situation. One of the key aspects of Rogan's commentary is how it intersects with scientific findings. While he is not a scientist, Rogan often references the latest research and expert opinions to inform his discussions. This approach has allowed him to bridge the gap between the scientific community and the general public, translating complex geological phenomena into terms that are easy to understand and engaging to his audience. Rogan's discussions about the recent unsettling signs at Yellowstone, such as the increasing size of the dome-shaped uplift and the appearance of fissures, echo the concerns raised by scientists. Monitoring, research, and preparedness. But how exactly do scientists know that this volcano is about to explode? The task of keeping a vigilant eye on the Yellowstone supervolcano involves a complex network of monitoring efforts, crucial for deciphering the subtleties of this massive volcanic system. Scientists and researchers are engaged in continuous observation, employing a range of advanced technologies to track any changes that might indicate shifts in volcanic activity. This diligent work is foundational in understanding the supervolcano's behavior, providing invaluable data that inform both the scientific community and the public. Central to these monitoring efforts are cutting-edge tools like GPS and INSAR. Beyond mere observation, scientific research plays a pivotal role in disaster preparedness. Understanding the supervolcano's intricate mechanisms allows researchers to develop potential strategies for mitigating the impacts of a possible eruption. This research is about predicting when an eruption might occur and about understanding how such an event would unfold and the best ways to protect lives and infrastructure. For instance, the study of past eruptions and the behavior of resurgent domes within the opening provides insights into the supervolcano's eruptive history and potential future activity. This knowledge is instrumental in developing evacuation plans, designing infrastructure that can withstand volcanic events, and implementing early warning systems to alert the public in a timely manner. In addition to the immediate human and infrastructural impacts, the eruption had significant environmental consequences. The ash fallout affected vast areas, damaging agriculture and contaminating water supplies, which worsened the humanitarian crisis. The eruption also left a large opening at the summit of Mount Pinatubo, fundamentally altering the mountain's landscape. One of the most enduring legacies of Pinatubo's eruption was its impact on the Earth's atmosphere. The sulfur dioxide ejected into the stratosphere reacted with water vapor to form a sulfuric acid mist that spread around the globe, creating a veil that reflected sunlight and cooled the Earth's surface. This atmospheric phenomenon provided a real-world case study for scientists studying the potential effects of aerosols on climate, contributing valuable data to the field of climatology. Furthermore, the eruption gave rise to advancements in the monitoring and prediction of volcanic activity worldwide. The successful forecasting and evacuation operations demonstrated the value of scientific monitoring and international collaboration in reducing the human toll of volcanic eruptions. In the aftermath, there was increased investment in volcanic research and monitoring, including the establishment of more sophisticated early warning systems and the deployment of new technologies for detecting signs of volcanic unrest. These examples illustrate the diverse impacts of volcanic eruptions, from local devastation and loss of life to global climatic changes. Each event illustrates the Earth's dynamic nature and the need for ongoing research, monitoring, and preparedness to mitigate the risks associated with volcanic activity. The study of past eruptions, along with continuous monitoring of active volcanoes, is crucial for predicting future eruptions and implementing effective disaster response strategies to protect communities and ecosystems in volcanic regions. As for Yellowstone's future, it remains to be seen if the dome-shaped uplift increasing in size is just a natural phenomenon or something far more dangerous. As we've journeyed through the depths of Yellowstone's volcanic heart, it's clear that vigilance, research, and preparedness are our best tools against nature's unpredictable might. Stay informed, stay curious, and join the conversation as we continue to unravel the mysteries of Yellowstone's sleeping giant.